All right, so first one is a March test paper, 2024, grade 9, KwaZulu Natal, from testpapers.co.za. All right, so first question, okay. Which one of the following numbers is irrational? What does irrational mean? There are different forms of number systems. They are the rationals, irrationals, integers, and so on. So rationals are, think of it as in rationals. This word here, rational, right? Rational in English just means to make sense. So a number like 3.5, that makes sense because it stops right there. Integer, just for reference, an integer is a whole number. So 3, 4, 5, 327, etc. Right? But back to rationals. Rationals are numbers that are rational, that make sense. So 3.5, 4.20, etc. Like they end there. Irrationals are numbers that don't make sense, like pi. I think you guys done pi. Pi is 3.14 dot 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 dot, and it goes on until infinity. That that doesn't make sense, and it's 3.14 ba 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 ba. That is irrational. Um, Another example of irrationals are, say, when you have a value that is like 2.22222, etc., two repeating, right? That can normally come from when you do one of these, right? So, what would this be? Would this be rational or irrational? Well, 4 is square root 4 is just 2, which is rational. Yeah. How about 5? Which numbers, if we square them, give you 5? It's tricky, right? This would be, this here would be 2.23606 dot 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 dot. Irrational, rational. So if you look at here, this one, this would be rational, right? This one, this is cube root of negative 27, which is equal to 3 negative. This is going to be what? So what this is saying is, easy way to figure this out is if you say which three numbers times it by itself will give me this. This would be 3 times 3 times 3, right? Which then would be equal to, that's 3 times 3, which is 9. 9 times 3 is 27. So the answer would be, negative 3. Just a side, if this was negative 16, we won't be able to do this. This would be something called imaginary number, which you don't have to know about, but this would not be possible. We can only do it if it's an odd number up here. This here is secretly a 2, so we can't do it. If it was a 4, we can't do it. If this was a 6, we can't do it. If it was a 5, we could do it. But this here is a whole number. Oh, another word for integers is whole number. This one is interesting because this looks like this root 5. So I would say that this here is the answer, A. I did leave out B because B could be a irrational number, but according to the curriculum, it's not considered one. Yeah. All right. Let's change the color. Fine, green. Which one of the following best represents 72 as a product of its prime factors? What are prime factors? Prime factors are factors which are prime. What does that mean? Prime means that it has two, it only has, what is this? Two multiples that can make itself. Let me show by example. So 3, right? You can only get 3 by saying 3 times 1, right? 7, you can only get 7 by saying 7 times 1. This is a prime number, this is a prime number. How about 8? Well, 8, you can get, say, 8 times 1. Haha, prime. No, because you can also say 4 times 2, right? And because this has 2, it's not a prime. I do apologize for the earlier mistake, but yeah, this only has 1 and 1, so it's prime. What about 51? Can you get 51 as a prime factor? As like, which one make up 51? Well, it's only 51 times 1. So let's look back at here. So they're asking us for prime factors, right? Well, this is not a prime factor. This one is not either, because you can get 9 times 1 and 3 times 3. Yes, that's a prime. That's a prime. That's not a prime. 24. 24 times 1 and 12 times 2. This is a prime? This is a prime. All right. Let's look at D. 2, 2, 2. Is 2 a prime number? Yes, 2 is actually the only even prime number. And then a 3 and a 3. Let's just make sure this does make 72. So if we say 2 times 2, which is 4, times 2 times 3 times 3, right? 4 times 2 is 8, times 3 times 3. 8 times 3 is 8, 16, 24, times 3. This would be, you can say 4 times 3, which is going to be 12. And then 3 times 2 is 6, plus that 1, 72. So D is the answer. This question, let's go for that color. So between which two consecutive integers, what did we say integers were again? They are, you can say they're whole numbers. Is the cubed root of 181, right? So in order to solve this, right, we can break down 181, right? So the cube roots that I think you guys know, right? So 1 cubed, let me do this over here. 1 cubed is equal to 1. 2 cubed is equal to 8, because it's 2 times 2, which is 4. 4 times 2 is 8. We got 3 cubed, which is 3 times 3, which is 9. 9 times 3 is 27. We got 4 cubed, which is 4 times 4, which is 16. And 16 times 4 is 64. Is 64. And we got 5 cubed, which is 5 times 5, which is 25. And then 25 times 5 is 5 times 5 is 25. Then 5 times 2 is 100. Oh, it's 10, sorry. And then 10 plus 2 is 12, which is 125. Okay, we're getting close. Well, we can actually now already begin to deduce which one it is, because 64 and 125 is not, like, those are both below 181, so it can't be A. Let's try 5 and 6. What is 6 to the power cubed? That is 6 times 6, which is 36, times 6. Because remember, whenever we're doing a cube, right, we are saying 6 times 6 times 6. If it was the other way around, it was 3 times 6, right? This would just be 6 plus 6 plus 6. If we were saying 6 to the power 4, that would be 6 times 6 times 6 times 6. Yeah. All right. So 36 times 6 is, okay, to work this out, we go 6 times 6, which is 36. 6 times 3 is 6, 12, 18, plus 3 is 21. So we have these two, it's 125 and 216. Now 181 is between these ones. Therefore, 5 and 6. Okay, which of the following given numbers is not an integer? Okay, so integer, a whole number. So, but we're not looking for a whole number. We're looking for ones that are not whole number because of the not, this not action word. So, D, whole number. C, whole number. 0? 0 a whole number or not? It is. This 5.5. If you see a 0.5 or comma 5, that means it's not an integer. All right. That's a nice easy 1 mark. What is the value of 7 squared square rooted plus the cube root of 8? Well, you see this and you're like, oh no, what do I do? Do I go 7 squared plus 8? But then what happens to that 3? Calm down. And then let's do this. So let's work out the first one, right? Square root of 7 squared. Just remember that whenever you have this, right? This and this cancel each other out, which will just have the square. So square, just have this value. So if we have 7 squared, this and this cancel each other out, so we just have 7. To work out this one, it's the cube root of 8, right? But can't we write 8 in a different way? Sure, we can say 2 times 4, 8 times 1, but that's not really useful in this question, right? Oopsie, I've made a boat. Anyways, we can write 8 as 2 times 2 times 2, right? Which we know from previous example, from this one here, is just 2 to the power cube, right? 2 to the power 3. And similar to that, because this is a 3, right? And this is a 3, they cancel each other out. So we have 2. So then we have 7 plus 2, which is equal to 9, which is C. Okay, this one is interesting. So 4 to the power negative 2 times 2 to the power negative 3 times 8 to the power 0. Interesting. So how would we work this out? Well, let's make them into a form we know, which is 1 over 4. Because we're taking it to the other side, we put the opposite sign, right? Times 1 to the power 2 positive 3 times, what is 8 to the power 0? 1, right? How about 224 to the power 0? 1. This is not equal to 0. Just remember, whenever anything to the power 0 is 1. So if we do like this, right, this is just equal to 1 over 4 squared times 1 over 2 cubed. Forget how this is done in grade 9, but I'm going to show you 2 methods. You can go 1 over 4 times 4. So 4 times itself 2 times is 16 times 1 over 2 times itself 3 times is 2 times 2, which is 4. Then 4 times 2 is 8. So then we can say, what is this? Let's ignore the numerators for now, and let's go, what is 16 times 8? Right? So 8 times 6 is how much? 8 times 6. Well, 8 times 5 is equal to 40. And then, so then 8 times 6 is just going to be 48, because we're just adding 8 in order to get to this. If that's confusing, don't worry about that. Which is going to be 48, all right? And 8 times 1 is 8. 8 plus 4 is 12. 128. Therefore, it's 1 over 128, which is B. Right, so 1.7. Ooh, this one looks interesting. Write the value in scientific notation of this times that. So, looking at the textbook, we can see that if you have something like this, right, you can just say, 3.7 times 5.2, right, times 10 to the power negative 4 times 10 to the power negative 3. This 3.7 times 5.2 You can use your calculator for this. It's equal to 19.24 then times 10. This will be times 10, negative 4, negative 3, right? Which is equal to, which is equal to negative 7. But we don't have anything like this negative 7, right? So how do we get one of these? Well, let's first see, right? If we move it all the way to this way, it would be 19.24 V12, right? That'll be, if we move it all the way this way, it'll be 1, 2, which means we'll have to minus by 2, right? Which is going to be negative 9, which is not the same as this or this. So this is out, right? This one here is after the 2, which is 1, right? We know that this is going to be minus 1, which will be negative 8, which is this not. So no. Running this with this one. Let's check. Moving it this way, which means we're going to be adding 1. It will be 1.924 times 10 to the power negative 6. So D is the answer. Determine the next term in the pattern given 8, 13, 8, 23, 28. All right. So what is the difference between these two? The difference between this is 13 minus 8, right? Which is 5. Between these two, 5. Between these two, 5. Between these two, 5. So then, So then the next one would be 5 also, right? And what's 28 plus 5? That is 33, right? Which is B. This one, let's see. 2, 8, so that's 6, right? Then when we come here, that's 128 and 512. It's 128, which is not 6 and 128. So it's not like the one above, right? So let's think about it. So let's see. If it's not plus in, maybe times in. So how will you get there? We get by 4, right? How about this one? If you go and do the calculation, also 4. This one, 4. This one, 4. So the pattern is times by 4, right? What is this? 8 times 4? What is that? Yeah, that's 32, which is equal to A. In the input table below, what are the values of A and B if the rule is minus 3t plus 4? Right, so let's try it for this one, right? So negative 3t, this is going to be t, right? T is negative 3 plus 4. Let's see if this gives us 13. This here is negative and negative make a positive. 3 times 3 is 9. 9 plus 4, 13. So this is correct. So if we have negative 3, right, and we substitute t is equal to negative 1, put that in there, right, plus 4, this would be negative and negative, make a positive, which is going to be positive, 3 plus 4, which is going to be, yes, 7. Let's look at the last one. We have negative 3, 0, plus 4, which is equal to 0 plus 4. I should have explained this before, but whenever you see these parentheses or brackets, right, that means that this number is getting times by that number. Right, so if you answer the question, we have a 7 and a 4, so it's going to be this one. All right.